Thank you all for coming out. It's 5 o'clock at VMware World. Usually do not get this level of attendance in spite of the registration, so I'm thrilled with that. That's awesome. So I am Brett Garino. This is Rebecca Fitzhugh. We'll be giving formal introductions as we get to each section of the session. I will be doing the CPU portion of this session, and Rebecca will be handling the memory portion. This is compute. So we're talking about vSphere performance troubleshooting root cause analysis. Okay, this is for the compute, and then we have another session that we do. It's going to be happening tomorrow that is on I/O, which is network and storage. So if you're intrigued by that as well, feel free to look up that session too. Okay? Now, as we get into this, we initially have the disclaimer, and you guys can read that. So I'm Brett Garino, and I'm a principal instructor at VMware. I work in VMware Education Services. So when we talk about troubleshooting and root cause analysis, though, I do just want to point out, primarily this session is going to be focused very heavily on key performance indicators around CPU and memory. So actual counters and their thresholds and what you should be looking at and why and how you should react to them. Okay? And we will be primarily looking at ESX top as a means of doing so. So if you're very comfortable with this topic already and this is something that you do all the time, you may not get as much out of this session. If you are new to this tool, you're going to get a whole lot out of this session. All right? Just want to level set and give you guys all the proper expectations as we go into this. But that's who I am. I teach. I'm also a VCDX. I'm VCDX 256, and Rebecca will give a formal introduction herself whenever she gets to it. Now, before we actually talk about CPU, when I hand off memory, before we actually talk about CPU, we're going to talk about ESX top, because this is the tool that we want to be using to analyze our Core 4 resource analysis. Right? This is a phenomenal tool. It's built into every single ESXi host. And that's part of what makes this so valuable to you. Because no matter what customer you walk into, they have this tool available for you to use. And there are a few tools that are as comprehensive as ESX top. Now I will tell you, the only limitation of this tool is the fact that it runs in real time. Now you can run it in batch mode, and you can have it actually record some data, and then you can replay that data later. However, it does not, by default, show you anything historical. Right? So if you're having an issue, this is a wonderful tool to use. It's my favorite tool to use if I'm having an issue in real time. If I'm looking at historical analysis, I might look at logs, vCenter server performance charts. I might go look at other things. Right? But this is not a tool necessarily, unless you were running it in batch mode when the problem happened, that is going to give you the opportunity to look at anything historically. So with that being said, how do I run ESX top? ESX top is going to be, it's the command. Okay? You go into the shell of an ESXi host, which you can remote into it using PuTTY, or you could use iDRAC or ILO, whatever you want to get into the host. You could have a KVM locally. But as long as you can access the shell of the ESXi host, you can run the command, ESX top. If you use a tool like VCLI, you'll have to use RESX top. But ESX top, if you're local to the ESXi host, is exactly what you're going to run. And this is not what you're going to see when you do that. What this is the help screen. So I always tell everyone, there's two things you need to learn ESX top. This and the command name itself. Now, as you go look at the different screens, and we've highlighted several of them up there, C for CPU, M for memory, there are 3 storage views. Okay, we'll cover those in that session tomorrow, and then we have N for the networking view, which will be covered in the session tomorrow. But CPU and memory is what we're going to zero in on. As you navigate these different views, always be mindful of the fact that the help screen will have different and unique options potentially on each view. So you need to familiarize yourself with that as well. Now, moving into actual CPU key performance indicators. As we look at this, we point out and we start with ready time, utilization, and load average. And those are for the ESXi host. That's on the left-hand side, highlighted in the blue box. In the green box, we've got virtual machine indicators. So we have ready time, co-stop, swap wait, memory limited. Okay, we'll be exploring these in more detail. But the first thing I want to tell you is, in troubleshooting, we need to recognize a few things. Number one, why are we having this problem? If it's performance related, it's because your consumer is asking for more than what your provider can give. On this screen, your consumer is on the right, the virtual machine. On the left, your provider is the ESXi host. That host is responsible for giving the resources to the VM. It's when we run VMs with more allocated resources than the host has physically available that we tend to run into performance issues, because we have oversubscribed CPUs or over-allocated memory. and we exceed the actual physical resources that are available on the box. So, provider, consumer. And I'm going to highlight this as well when we start looking at the screenshots of ESX Top, because that's how you need to be thinking when you approach ESX Top. In addition, the hypervisor is an abstraction layer. It abstracts the physical hardware resources that are on the box. So what that means is we have the virtual machine consumers sitting up here, their guest OS is above that, and the applications above that. Everything originates with the application making the request for CPU or memory, and then has to pass through the guest OS, subsequently pass through the virtual machine hardware layer where we have individual hardware devices such as vCPUs and VRAM, and then that passes through to the VM kernel, subsequently to the actual hardware local to the ESXi host where we actually make the request of the physical hardware, if it's available. So when it's not available, what happens? We get latencies, the counters get worse, and these are the metrics that we use to identify when those things are taking place. And we have to be able to recognize whether the problem is a VM or a host. So, moving forward, we look at using RESX Top interactively, or just using ESX Top interactively. Wherever you see RESX Top in these slides, you can substitute ESX Top. I just use the remote command if you're using VCLI. So, we point out you just enter C or M to access the CPU or memory pages. And remember, H is going to let you see all of the options within there. So if I run ESX Top, this is the default view. It's always going to start with CPU as the default view when you run the command. Now everything above that gray line is your host, your provider. Everything below that gray line is a consumer. Now, the consumers are not just virtual machines. There are also services that keep the ESXi host running, such as host D, or something relative to logging, or it could be something relative to the I/O injector. There's a bunch of different services that run on the ESXi host. So as we analyze this, one of the things that we want to be able to do is truncate the view down to just virtual machines, unless I'm troubleshooting a resource contention issue, maybe with a host service, which is unlikely. Typically when I come in here, I'm looking at virtual machine to ESXi host resources. So we can limit the view to just show virtual machines. Currently, this view is only showing me services. That doesn't do me any good if I want to see the virtual machines themselves. So above the line, you have the ESXi host physical resources. And what we can see on this host is you've got the timestamp going from left to right. We have the timestamp, and then we have the number of worlds. Okay? Now, worlds are groups of services, like process trees. Okay? So a virtual machine is composed of a variety of worlds. Every vCPU you give to a virtual machine is another world, so that you can analyze the vCPU's performance independently. Because sometimes you might be having a problem where a virtual machine with a dozen vCPUs is only using 3 of them. We would want to react to that if we were seeing that kind of behavior. So, as we look at this, we have the number of worlds, and then you have CPU load average, which is highlighted in the red box. And there are 3 numbers. The first number is the last minute of load on this ESXi host. The second number is the last 5 minutes, and the third number, it's either 10 or 15 minutes, I'm not sure. It's one of those 2. But it's more historical than the 1 or the 5. So what we can see here is the trend on this is that this host has gotten extremely busy, and it's in CPU contention physically. Okay? We want that number to be 1.00 or less, generally speaking. So in this case, the fact that it is 2.0 plus is very bad. Okay? I would expect to see some negative CPU counters as a result of this. So, as we look at the numbers, we have CPU used. That's a wonderful metric that tells you how much of your CPU is spending its time actually functioning and doing work. A lot of times, your CPUs will be idle. Idle is not necessarily a bad thing, okay? One of the highest numbers you're going to find on most of your virtual machines that aren't very busy is, in fact, idle. Because when vCPUs aren't busy, we park them in an idle world. So, on the right-hand side over there, I believe that is ready. Yeah, it's hard for me to see from here. So we've got ready up there, and ready is something that we're going to be talking about. That is your primary key performance indicator for CPU. Okay? So we'll talk about what ready means as we go into this. First off, I want to introduce you to the CPU co-scheduler. Now, there was a time in VMware's history where if I created a virtual machine with 4 vCPUs, and I only needed one of those vCPUs, we had to send all 4 and schedule them concurrently. Okay? This is when we had what was called a strict CPU co-scheduler. We have not had this since ESX25, I believe. However, the idea persists in many circles that we still operate this way. We don't. So what we have instead is a relaxed CPU co-scheduler, which means if I create a VM with 4 vCPUs and in this clock cycle I only need one of them, only one of them will be scheduled. The remainder will be scheduled to an idle world. And this sounds great, right? It's idle. That doesn't cost me anything, right? We'll learn about something called co-stop in just a bit that informs us that idle is not always the best thing. We want our virtual machines to be right-sized so they actually use the resources we give them. So, this is the CPU co-scheduler. And if you were to Google for that phrase, you would find a white paper that I ripped this out of that is based on ESX 5.1. This shows you the various states that a CPU can be in. And this is invaluable to understanding how the CPU works and functions and the different counters that the CPU could be experiencing as part of its normal functions. Okay? So, when we start this off and we have a new CPU operation, it can go to run or ready. Run is ideal. Run is calculated as part of used, which we said earlier that used tells you how functional and how used the virtual CPU is. So run is ideal. I want my virtual CPUs to be running as often as they'd like. But what happens is we increase consolidation ratios on the boxes. Right? We put more virtual machines on them, and we give the virtual machines more resources, and inevitably we create conditions where there are more vCPUs than there are actual cores on the box. And this leads to CPU contention, which can ultimately lead to scheduling issues for the CPU, which in turn can drive values like ready. Ready is a metric that indicates that my virtual machine's vCPU wants to run, but it can't. We'll talk about why not in just a bit. Co-stop is a metric that we'll talk about in more detail as well. And that helps you to determine when your virtual machines have been given too many vCPUs. So in the process of right-sizing virtual machines, I can use ESX top to help me make that determination. Or maybe for many of you, you have vRealize Operations Management, and it tells you when it's time for you to resize a virtual machine, which is wonderful. But what if you wanted to actually go validate what it finds yourself? You could use ESX top to do so, because the metrics that it uses to make those determinations are the same ones we're going to be looking at here. So weight, although it's red on this slide, is not something that you generally have to worry about. Okay? Weight values are generally pretty high on virtual machines that are idle, and we don't worry about that too much. I don't know why they opted, when they authored this paper, to make weight red. It makes you think that it's bad. It's really, I really don't pay much attention to weight. There is a metric called VM weight that includes I/O overhead of processing network and storage I/O within the virtual machine, and I do pay attention to that if it's excessively high. But we don't cover that in this session. So just something to mention. So the CPU scheduler is responsible, the relaxed CPU co-scheduler, to call it by its actual name, it is responsible for scheduling vCPUs against physical cores on your ESXi host, or logical threads that are represented atop the physical cores. If you're hyper-threaded, you have 2 logical threads per core. Don't schedule against hyper-threads. Avoid it if possible. All right? I try to never build a single VM on a ESXi host with more vCPUs than I have physical cores to give on the box. Okay? So, but the CPU co-scheduler is responsible for determining which core on the box a vCPU should be mapped to for the operations. And that's an important thing, because if you think about it, what happens if I move from core 0 to core 1 and I'm currently a virtual CPU? Do I still have access to all of my last layer cache, my layer 1 cache, the cache that's on the processor? This can impact memory operations on databases and things like that. So when we're looking at migrating vCPUs, the CPU co-scheduler is responsible for making that determination, and it does so with a decision-making process that occurs every 2 to 40 milliseconds. So it's constantly migrating vCPUs if necessary, but it prefers to leave them in place whenever possible. All right? Now, a world, we said earlier, is like a group of services. Every virtual machine is made up of worlds. You have the MKS world, mouse, keyboard, screen. You have the VMM world, the virtual machine monitor, which is a resource that every single virtual machine resource request has to pass through. So every CPU request, every I/O request, every memory request actually has to pass through the VMM. And then you have your CPU world. And there are other world types that we're not going to cover in here, but you're welcome to look at them inside of your ESXi hosts when you're using ESXtop in the CPU view. Your virtual machine will have additional vCPU worlds for every single CPU you add to a VM. And you don't see them by default on the screen. You have to strike the letter E on the keyboard when you are on the CPU view and identify the identifier of the row, which is a numerical value, generally 6 or 7 characters, numbers long. And after you actually identify that, it will expand to show you all of that virtual machine's worlds. Why is this important? Because if I see a virtual machine that has a high ready value, it could just be on one of the vCPUs, whereas the other vCPUs could be doing nothing. Well, that indicates a problem, right? My virtual machine should be trying to use all those other vCPUs. So that's why it's important that we recognize the different worlds and our ability to expand and then roll up the worlds so that we can see all of the worlds that make up a virtual machine. So now we're going to talk about co-stop, okay? And co-stop is a metric that is only going to be above 0 potentially on VMs with more than one vCPU. So you have to have what we call a VSMP-enabled virtual machine, which is virtual symmetric multiprocessing. Couldn't even get that out. So if you have more than one vCPU on a virtual machine, you potentially will see co-stop greater than 0. This is a metric you want to always be 0. When will it not be 0? Well, if you've given a virtual machine too many vCPUs, and the virtual machine is not using all of its vCPUs, then co-stop will increase as we have to engage in co-stop operations. What is a co-stop operation and why does it happen? When you have virtual CPUs on a VM that are actually running and virtual machines vCPUs that are being scheduled to the idle world, as that takes place, skew is being generated between the vCPUs because one of the vCPUs is advancing and running while the other is being held behind. When this skew breaches a certain threshold, and I frankly don't know what it is, but you will have a co-stop event. Okay? So when the CPU co-scheduler recognizes that the skew breaches a certain threshold, a co-stop occurs. And what that does is, for an entire clock cycle, we do not let any of the vCPUs run. They are all halted in unison to reset the skew back to 0. You can't process when this is taking place. This is why it's important to right-size your virtual machines. So when, relative to co-stop's findings, should you go and reduce the number of vCPUs on a virtual machine? The answer to this is we generally want to see co-stop lower than a value of 3 in ESXtop. And if co-stop is greater than 3 in ESXtop, then I seriously need to consider reducing the number of vCPUs on my virtual machine. It will likely increase performance when you do so because you will have fewer co-stop operations and more opportunities to run the vCPUs on the box. When we look at additional CPU performance factors, idle virtual machines. Okay? You could have idle virtual machines. You've probably heard the recommendation. And we tend to think that idle has no cost. Idle, of course, has a cost, right? We sometimes call these zombie VMs or vampire VMs because they just sit there and suck resources and they're not doing any work. So we want to mitigate idle VMs in our environment, and we want to make sure that we don't leave hardware devices on our virtual machines that are not necessary because you have timer interrupts. And we pull those hardware devices in the guest OS, and that requires CPU utilization. Leaving things like screensavers running inside of virtual machines wastes CPU cycles. So we want to take that into consideration. CPU affinity is something that will pin a vCPU to a physical core. This is never a good idea. Okay? There is no reason I've ever seen to do this in a production workload. Okay? So you literally pin a vCPU to a physical core on the box. This reduces the efficacy of the CPU co-scheduler. You do not want to do that. Let the CPU co-scheduler do its thing. It's faster than you will ever be at determining which core should be in use. SMP-enabled virtual machines. If I have those, which we all do, those are virtual machines that have more than one vCPU on them. I need to make sure that I'm monitoring those for co-stop metrics. Okay? If I have performance issues on a virtual machine with lots of vCPUs, I'm going to jump in ESXtop and I'm going to zero in on co-stop and see what the metric is. And if we have insufficient CPU resources for the demand, how does that happen? It's because we've allocated more vCPUs on the box than we have physical cores to give. And ultimately, what that results in, when those